Hi everybody, my name is Nicolas Cherniavsky and I'm the president of the Rejuvenation Science Institute, a non-profit research institute based in Brazil focused on promote research and science dissemination in the rejuvenation, longevity and aging space. Today we are going to have a special interview with the most known name of the rejuvenation field, Aubrey the Great.
Aubrey the Grey, the president of the Longevity Escape Velocity Foundation. So, hello, Aubrey, how are you?
I'm very well, thank you. Thank you for inviting me.
In order our audience know a bit more about your foundation, can you explain briefly what is your foundation and their goals?
Certainly. So I have led a succession of three different organizations over the past 20 or 25 years. And I've done that in order to support and promote research that will bring aging under comprehensive medical control in the future. Now, the way that I hope to do that is by pursuing a research program that I first put forward in the year 2000, 25 years ago. And that approach involves repairing a lot of different types of damage that the body does to itself throughout life and that eventually make us sick. Now, that means that it's a divide and conquer approach. First of all, we need to develop technologies, medicines that will repair these various different types of damage. And then we need to put them together. We need to give them all to the same individual at the same time. So, in my first two organizations, I was focused on the first step of that, developing these components, these individual treatments. And in LEV Foundation, my current organization, I'm focusing on the second step, putting them together. Now, this is kind of getting ahead of myself because some of the components are not ready yet, but some of them are ready, not just because of our work, but because of work that people in the community have done. And therefore, we have enough tools now, enough components, that we can start the process of putting things together in combination and demonstrating which of them are additive, which of them can give more benefits in terms of extending life in combination than they can individually. Now, this is all being done in mice, not in human beings, but you've got to start somewhere, and this is the right place to start.
Aubrey, we know that you already did a big experiment called Robust Mouse Rejuvenation 1. And we saw some updates from you in the social media, but we didn't saw a complete result. Like, which were the final results of this first test, in which you tried four different therapies. So, could you give us a perspective of the final result, if those results already exist?
So there are many different types of final result. One result is lifespan. How long did the mice live that were being given different types of treatments? We have mice that were given none of the treatments, mice that were given all four, mice that were given just one of the four, mice that were given three of the four. That's 10 different treatment groups. And we absolutely have publicized on social media, as you say, the final results of that. But in addition to all of that, we made many, many measurements of the health of the mice, both throughout the experiment as the mice were getting older, and also at the end, when mice died, we would isolate and store some of the tissues of the mice that would be available thereafter to analyze to see what was going wrong in those tissues. So All of that data is still being processed. At the moment, we are only processing the non-invasive data, not the tissues, because the tissues are still stored. They have not yet been analyzed. But all of the things like, the trajectory of body weight, or visual things like curvature of the spine or loss of hair, loss of fur. These are things that we got lots of data on. Also behavioral stuff like, memory and eyesight and hearing. These are things that it's possible to measure in mice. We did all of those measurements. Also physiological things like agility. There's a test called the rotor rod test, a very standard test. And strength. You can measure grip strength of mice. You can measure, you know, things in the blood like glucose tolerance. We did all of these things, and all of those types of data are still being analyzed. So we will be reporting all of those things, both in social media and in academic publications in due course.
As your foundation, the name of your foundation is Longevity Escape Velocity Foundation. The longevity part is especially important regarding these results. As far as I remember, there wasn't a very strong extension on the longevity of the rats of the mice. Could you explain a bit more the longevity result and what it means? Does it mean that the therapies don't extend the life of the mice or something else?
So, if you look at the four interventions that we used in the first experiment, one of them was not a damage repair intervention at all. It was a calorie restriction mimetic called rapamycin, which is the gold standard right now. It's the most effective calorie restriction mimetic that we know. And we included that as a positive control, as scientists would say. We wanted to show that we were doing the experiment correctly. And sure enough, rapamycin gave a very significant life extension, just the same as it has in other people's hands. So that's all great. Then the other three interventions were damage repair. We were rejuvenating the bone marrow, we were extending the telomeres, and we were getting rid of senescent cells. These are three very different types of damage repair. And the result that we got was that we definitely showed additivity. We showed that if you do all three of these things, you get more impact than if you do any one of them. But you're quite right. The overall magnitude of the effect that we got was not very inspiring. We did not get significantly beyond what you can get with rapamycin on its own. And therefore, we conclude that we just need to do more things. Since we always knew that damage repair is a divide and conquer strategy, something in which you need to do a lot of things, multiple things to the same individual at the same time. Now, that means that, you don't know how many things you're going to need to do in order to tick all of the boxes. So now we believe that the right way to go forward is to do a lot more things. And that's why in the next experiment that we want to do, RMR2, we're planning to put 8 things together, not just 3. We'll actually probably give all the mice rapamycin just in order to, because that's done, right? We know how to do that. And therefore it's a kind of, just like it improves the signal to noise ratio. It clarifies what's going on.
But regarding this second experiment, I mean, do you have an idea of the time or a timeline when you start these experiments?
I wish. We do have a design of the experiment, and you can read that on our website, levf.org/RMR2. But in terms of when we are going to do the experiment, that's all about funding. The nature of these studies is that most of the expense happens at the beginning. First of all, because we have to start with mice that are already fairly old, and old mice cost a lot of money. And secondly, because most of the treatments that we're going to do are rejuvenation treatments that we do once at the beginning of the experiment, and then we don't need to do them again. After that, we just keep the mice alive, and that doesn't cost very much. So what that adds up to is that I basically need to raise roughly $6 million before I can pull the trigger. Once I get $6 million in the bank, we will start this experiment, 10 minutes later, right? We will do it at once, but we can't do it until we have the money.
As our audience may know, and you certainly know, our institute is carrying out an experiment with small cellular vesicles to reproduce an experiment that rejuvenated the rat strongly. So just to use this opportunity, what do you think about this experiment and what it can add to the rejuvenation science community?
I'm really delighted that you guys are doing this study. There have been a few studies done by other people, including the one that you are aiming to replicate, which have shown very good benefits from injecting exosomes, extracellular vesicles, from young animals into old animals. And one thing that appears to be, a, a conclusion from these studies is that these extracellular vesicles do not even need to come from the same species as the organism into which they are being injected, which is really, really surprising, but it's been reproduced by you and by others enough that we can be sure that it's true. Now, we already have been planning to use extracellular vesicles of some kind in our next study. There are several ways to do that, and many of the reasons to use a particular approach come down to costs. In particular, I'm very, very interested in the fact that the study by Harold Katcher's group that you are attempting to replicate involved a really high dose of extracellular vesicles, much higher than what most people have used. And it makes sense to me that using a really high dose could be the key to having a big benefit. So we are very interested in what you guys are doing.
Okay, let's hope our experiment helps you. Regarding RMR2, eight different therapies, are you prepared for the possibility that instead of a simply additive effect, you have some therapy that rejuvenate much more the mice than the others? I mean, what this would change,
So the purpose of these studies is to gain information, to understand what works and what doesn't work. And I was very careful when I came up with the study design that we use for RMR1 and that we are also going to use for RMR2. The big thing is that we want to find out basically which things work better, which things don't work. And we also want to find out which things are additive and which things are not, which things cancel each other out for reasons that we had not expected. The way that we do that is actually really simple. We have a group that's getting all of these treatments, and we have another group that's getting none of them. So that's obvious, right? That's just the control group. But then in addition, we have groups that are getting just one of the treatments. So we can compare each treatment with each other treatment individually And we are doing it all in the same experiment, in the same laboratory at the same time. So there is much more uniformity than you would get if you were just comparing publications from different groups done in different places at different times. We can get a better idea. And then on top of that, we have treatment groups that are getting all but one of the treatments. And that is how we find out whether there are antagonistic interactions where two treatments are cancelling each other out. The way it would show up is that some of the groups that are getting all but one of the treatments would do better, would live longer than the group that's getting getting all of the treatments. And so that works. That design is independent of how many treatments we're looking at. It's what we did with RMR1 with just 4 treatments, and it's also what we're doing with RMR2 with 8 treatments.
And let's say you have a strong result in this next experiment. RMR. For me, it's not easy to say RMR2. You have a strong result. Let's say in terms of longevity of the mice, better than the first experiment. What would you expect to make a RMR3 or to take another animals, other species, or what would be the next steps?
Well, of course, we are not just looking at what we at LEV Foundation would do. I strongly believe, I'm very sure, that if we get a strong result, so first of all, let me explain what a strong result really means, right? If you take mice that are already in middle age, so they're about 1.5 years old and they would normally live to about 2.5 years, and you do simple things like calorie restriction, you can already extend their lives by about 4 months, right? That's been known for half a century, right? It's completely known. You can also do that basically the same amount with calorie restriction mimetics, or at least you can do it with the best calorie restriction mimetic, which is rapamycin. But nobody's been able to improve on that. So for me, what it means, what a success means, is improving on that 4 months. My stretch goal is to get to 12 months so that the mice live on average to 3.5 years rather than just 2.5. Even if we got to 8 months, that's still doubling the effect size that anyone's achieved before. So that's still really dramatic. Now, you think about what that means for the research community. They're looking at all of this and they've seen that we've made no progress for 50 years, for half a century. And then suddenly you double or treble the effect size that you can get. Everybody will immediately know that we're in a different world. So it won't be just LEV Foundation. Everybody, every researcher in the biology of aging will be jumping on that and doing a wide range of other experiments. And absolutely, some of those experiments will be in other species. But what I actually care about more is what's going to happen in the wider world outside of the research community. I believe that when the research community decides that there's been a big breakthrough, that's going to change public attitudes. The attitudes of influencers and the attitudes of the general public. And of course, that means it's going to change the policies of governments. And it's going to, launch a proper war on aging. I want us to make aging the new COVID. I want us to take aging as seriously as we took COVID 6 years ago. And once we have reason to believe that there is some chance of success, which is, of course, what we did think at the beginning, immediately when COVID came along, then I believe we will try. We will really we'll have a proper war on aging.
Yes, I have to say that the rationale of the you just mentioned is what we also use in our institute to the longevity study. The world record for rats is 4 years. If we, I mean, healthy and normal rats, not genetically modified. If you're able to go to 5 years old, a rat, it would be the equivalent. So I also think everything will change. But in our institute, we work with the perspective not only to change the external part, because I have serious doubts about what a mice or a rat living beyond the maximum lifespan can do publicly. So in our institute, we work with the perspective of, even if the world doesn't understand the meaning, to go forward in some way. So do you have an alternative plan if you are able to reach 12 months beyond the maximum lifespan? And okay, some scientists say fine. Do you have a plan, an alternative plan, like, okay, so let's do another things to go forward in your foundation?
I do not really think in terms of one plan or another plan or another plan. I don't think of alternatives. For me, I pursue all plans simultaneously, right? Now, the reason why this particular approach is the focus of my organization is because I think it's the most promising plan. But that's just a comparison. I don't say that no other plan is promising at all. I certainly don't say that. I'm very happy that lots of other organizations, both non-profit and for-profit, are out there pursuing other plans in parallel with this. But I still think that this is the approach that's most likely to work. And the reason I think that is because I think it's the approach that has the best chance of changing the public statements of other subject matter experts, other people who are respected authorities in the biology of aging. I've been saying for 20 or more years that we have a good chance of bringing aging under medical control if we try. And I have been attaching time frames to that statement. I have been saying that I think there's a 50% chance of getting to complete control of aging by such and such a date. None of my colleagues have been doing that. And I believe that the reason they haven't been doing it is because they rely for their funding on peer review, on being supported by each other. And that's really difficult. So we need a sufficiently dramatic result to give those people permission, if you like, to say the same kinds of things that I've been saying for a long time. Once all or most of the most prominent people in the field are attaching timeframes to, even probabilistic timeframes, to the idea of bringing aging under proper medical control in humans, not just in mice, then everything's going to change. The influencers of this world, Joe Rogan, Lex Friedman, Mr. Beast, these people are going to be, they're going to notice. And they're already clearly very interested in aging. They have us on their shows quite often. So it's a question of how committed they are willing to be. And once they see that the subject matter experts are much more optimistic than they used to be, optimistic enough to make time frame predictions, everything's going to change.
Regarding the goal of extending the life in mice, in our experiment with rats, we're thinking about the possibility, because you are bold in your goals and predictions, so you will certainly understand. If we are able to reproduce the 67% of epigenetic rejuvenation and also memory and grip strength, we maybe it's not just extending the life of the rats, but maybe extending it indefinitely. And why am I saying this? Because if you extend the in RMR2, the life of the mice in, 8 months or 12 months, uh, it's the general public won't understand it in the same way that if you simply make like immortal mice.
You're completely right. The public do not care about mice. The governments do not care about mice. Honestly, I don't care about mice. But I do care what mice tell us. What we have to ask ourselves here is when you can extend the lives of mice by a year, by 12 months, what does that mean for the likelihood that that we could do the same thing for human beings sometime soon? If you can't even do any better in mice than you could 50 years ago, then it's perfectly reasonable for people to say, well, let's wait and see. Let's not, try to, invest a lot of money into doing anything for human beings yet, because we have no idea where to start. Whereas if there's a big breakthrough in mice, then that changes the argument. It changes the balance of intuitive probabilities. It changes the whole attitude that people will have. They still won't care about mice, but they will understand because Joe Rogan will be telling them, right? They will understand that it looks like we might actually be able to bring aging under control fairly soon in humans.
But sorry, Aubrey, my question was more about the difference between extending the life of the mice and uh, if you rejuvenate them enough, you can extend it indefinitely.
Okay, now I get it.
If you just extend the life of the mice, you still need Joe Rogan to tell people that that is important. But if you create uh, life mice that live indefinitely, it's you don't need Joe Rogan.
Well, kind of. So first of all, it takes a long time to show that an organism is living indefinitely. Supposing we have our mice and normally they live to 2.5 years, and we start treating them when they're 1.5 years old, and then after 2 more years, when they are 3.5 years old, which is what I'm aiming for, right? Supposing then almost all of them are still alive. That says, maybe that means that almost all of them will still be alive when they're 4.5 years old. But we won't know that for another year, and so on, right? So it's not really the way to think about it, right? The fact is, also, that's not going to happen. I have this concept, of course, that I have described for many years called longevity escape velocity. And that's all about rejuvenation. But what it emphasizes is that you can't get indefinite lifespan just by applying the same panel of treatments over and over again. If you do that, then yes, you will continue to repair a certain proportion of the damage that the body is doing to itself. Let's call that the easy damage. But there will also be difficult damage that the treatments just don't work on. And that difficult damage will also continue to accumulate, and that will kill the mouse or the human being eventually. So the idea of longevity escape velocity is all about scientists continuing to improve the comprehensiveness, the quality of these treatments. so that we can continue to re-rejuvenate the same individuals over time, even though the damage that their body contains is inherently more difficult to treat. Now, what does that mean? That means that actually it's easier to get to longevity escape velocity in a really long-lived species like humans than it is in a short-lived species. I think it's touch and go whether we will ever reach longevity escape velocity for cats and dogs, right? And I'm absolutely certain that we won't ever reach longevity escape velocity for mice or rats because they just need we need to do too much. There's too many things that we need to figure out, and we don't have they're not giving us the time. They're going to die in the meantime.
I understood. Yes. Okay. It is related. Your vision about the indefinite, the possibility of indefinite lifespan is linked with the theory of aging of the accumulation of different type of damages. Okay. Okay, Aubrey, thank you very much for this interview. Everybody is cheering for you, even if they don't say it aloud. So thank you, and we'll see you another time.
Thank you very much for having me.
Thank you everybody for watching. To help the work of the Longevity Escape Velocity Foundation, the LEV Foundation, led by Aubrey the Grey, you can donate in the link below. Also, our research institute, the Rejuvenation Science Institute, the ICR, is also looking for funding for our rejuvenation experiment with rats, in which we will try to reproduce Harold Katcher's seminal rejuvenation experiment. You can learn more about that experiment in the videos from our channel linked below. And you can donate to the ICR as well. The link is also below. Thank you very much.